sampling. Cluster sampling is a method used extensively by government agencies and certain private research organizations. In cluster sampling, we begin by dividing the demographic area into sections. Then we randomly select sections or clusters. Every member of the cluster is included in the sample. For example, in conducting a survey of school children in a large city, we could first randomly select 5 schools and then include all the children from each selected school. So rather than randomly select, 200 children from a population of, 5 million kids, you simply select 2 schools with 100 students each. Randomly select 2 schools and you have 100 students each. So that is called cluster sampling. Okay. Often a population is very large or geographically spread out. In such cases, samples are constructed through a multi-stage sample design of several stages, when the final stage consists of clusters. For instance, the government current population survey interviews about 60,000 households across the United States each month by means of a multi-stage sample design. For the current population survey, the first stage consists of selecting samples of large geographic areas that do not cross state lines. So you want to interview 60,000 households, right? So first stage, you select samples of large geographic areas that do not cross state lines. That is, you take entire areas that sit within each state. These areas are further broken down into smaller blocks, which are stratified according to ethnic and other factors. Stratified samples of the blocks are then taken. Stratified samples of the blocks. Okay, so then you're basically choosing people randomly within this each stratum. Finally, housing units in each chosen block are broken into clusters of nearby housing units. So there are several stages here, you see. A random sample of these clusters of housing units is selected and each household in the final cluster is interviewed. Okay. Convenience sampling, that's another method. Convenience sampling simply uses results or data that are conveniently and readily obtained. In some cases, it may be all that is available, and in many cases, it's better than no information at all. However, convenience sampling does run the risk of being severely biased. For instance, consider a news person who wishes to get opinions of the people about a proposed seat tax to be imposed on tickets to all sporting events. Revenues from the seat tax will then be used to support the local symphony. So, who do you ask? Do you ask the local symphony people or do you ask the people who are attending sporting events? You see, so you cannot just conveniently choose one over the other. The newspaper stands in front of a concert hall and surveys the first 5 people exiting after a symphony performance who will cooperate. This method of choosing a sample will produce some opinions and perhaps some human interest stories, but it certainly has bias. It is hoped that the City Council will not use these opinions as the sole basis for a decision about the proposed tax. It is good advice to be very cautious indeed when the data come from method of convenience sampling. So in future, you could be researchers in this area. So when you're studying somebody else's work, check for convenience sampling. Sometimes convenience sampling is used and that has to be contested. So a summary of the sampling techniques. Random sampling. You use a simple random sample from the entire population. Stratified sampling, divide the entire population into distinct subgroups called strata. The strata are based on a specific characteristic such as age, income, education level, and so on. all members of a stratum share the specific characteristic. Draw random samples from each stratum. Systematic sampling. Number all members of the population sequentially. Then, from a starting point selected at random, include every kth member of the population in the sample. Cluster sampling. Divide the entire population into pre-existing segments or clusters. The clusters are often geographic. Make a random selection of the clusters. Include every member of each selected cluster. That's the difference between cluster and stratified sampling. In stratified sampling, you have divided the population into strata, but you are drawing random samples from each stratum. Whereas in cluster sampling, you have divided the population into clusters, include every member of each selected cluster. Okay. Multi-stage sampling use a variety of sampling methods to create successively smaller groups at each stage. So multi-stage, as the name suggests, you are going to break your population in over time, over several stages. The final sample consists of clusters. Convenience sampling. Create a sample by using data from population members that are readily available. We call the list of individuals from which a sample is actually selected the sampling frame. The list of individuals from which a sample is selected is called the sampling frame. Ideally, you are taking random sample from the entire population. In other words, ideally, the sampling frame is the entire population. However, from a practical perspective, not all members of a population may be accessible. For instance, using a telephone directory as the sample frame for residential telephone contacts would not include unlisted numbers. Okay? When the sample frame does not match the population, we have what is called undercoverage. Undercoverage means the people you selected from is not the entire population. Okay, quite a few, somebody from the entire population was not even in your radar, so to say. In demographic studies, undercoverage could result if the homeless, fugitives from the law, and so forth are not included in the study. Okay, so a sampling frame is a list of individuals from which a sample is actually selected. Undercoverage results from omitting population members from the sample frame. In general, even when the sampling frame and the population match, a sample is not a perfect representation of a population. Therefore, information drawn from a sample may not exactly match corresponding information from the population. This is very important, guys. You used an example. Say you wanted to study people's height and in New York City, and then you simply selected certain people in your neighborhood. Okay, whatever. And then based on that, can you say something about the entire New York City? We can't. Really, we can't. So information drawn from a sample may not exactly match corresponding information from the population. To the extent that sample information does not match the corresponding population information, we have an error called sampling error. So how do you have sampling error? When information from the sample does not match the corresponding information of the population. A sampling error is the difference between measurements from a sample and corresponding measurements from the respective population. It is caused by the fact that the sample does not perfectly represent the population. A non-sampling error is the result of poor sample design or sloppy data collection, faulty measuring instruments, bias in questionnaires, and so on. All right. Okay, so this ends the lecture slide for section 1-2. Next video will cover problems from section 1-2. Until then, bye.